And now we have the next topic. We have electric charge and electric field. In this video, we take a look at the concept of electrostatic force. While mass is a property of matter that brings about attraction, interaction, i.e. gravitational force, electric charge may be seen as a property of matter that brings about both attraction and repulsion interactions. There are two types of interactions for electric charges because there are two types of charges. We have positive charge and negative charge. Unit of charge is Coulomb, capital C. Variable for charge is small q. So q may be positive or it may be negative. So you might have q is equal to positive 5 Coulomb. Q might be negative. Q is equal to negative 5 Coulomb. You have two types of charges, which brings about two types of interaction. Attraction interaction and repulsion interaction. And like mass, charge is a conserved quantity. Say you have an object of total charge 10 Coulomb. You divide the object into smaller parts. The charge is conserved. If you add up the charges of the parts, it should still be equal to the total charge, to 10 Coulomb, for example. Q total is equal to Q1 plus Q2 plus Q3 and so on. Summation of all the individual charges. Examples of charged particles are the basic particles that make up the atom. You have electrons and protons, with neutrons being electrically neutral particles. You have the electron charge, Q electron, is equal to negative E, where E is the electron charge magnitude, 1.602 times 10 to the negative 19 Coulomb. So Q electron is equal to negative E is equal to negative 1.602 times 10 to the negative 19 Coulomb. Neutron is an electrically neutral particle, so the charge of a neutron, Q neutron, is equal to 0. Whereas the proton, the charge of the proton, Q proton, is equal to positive E, same magnitude as the electron charge but opposite in polarity. The electron is negatively charged particle while the proton is a positively charged particle. Q proton is equal to positive E is equal to positive 1.602 times 10 to the negative 19 Coulomb. Also given are the masses of the particles. You have the electron mass, the neutron mass, and the proton mass. M electron is equal to 9.109 times 10 to the negative 31 kilogram. M neutron is equal to 1.675 times 10 to the negative 27 kilograms. And M proton is equal to 1.673 times 10 to the negative 27 kilograms. Please take note of these values of the charges and masses of the basic particles that make up the atom. Due to the electron charge, objects may attract or repulse each other. as previously mentioned. Attraction and repulsion interaction. The magnitude of this interaction force is referred to this electrostatic force. The magnitude of this electrostatic force is given by Coulomb's law. You have two charged particles, particle 1, particle 2. Because of their charges, they will interact with each other. The interaction force, the electrostatic force. The magnitude of this force is provided by the Coulomb's law. F is equal to K Q1 Q2 over R squared, where Q1 is the charge of particle 1, Q2 is the charge of particle 2, and R is the distance between the two charged particles. And note that R in the equation is squared. You have R squared K Q1 Q2 over R squared. K is a constant referred to as the electrostatic constant or Coulomb's constant. Is equal to 8.99 times 10 to the 9th power Newton meter squared per Coulomb squared. Also note that Q1 and Q2 are enclosed in absolute value. That's because we're talking about magnitude of the electrostatic force. And magnitude should always be positive, but Q1 or Q2 may be positive or it may be negative. So to get rid of any negative sign, we have the absolute value. Absolute value of Q1 times Q2. Now, the Coulomb's constant K is equal to or has been found to be equal to 1 over 4 pi epsilon naught. So F, Coulomb's law, the magnitude of the electrostatic force, is also equal to 1 over 4 pi epsilon naught Q1 Q2 over R squared. Epsilon naught is another constant to take note of, the permittivity constant, and it's equal to 8.85 times 10 to the negative 12 Coulomb squared per Newton meter squared. Now, force is a vector quantity. It has both magnitude and direction. The magnitude of the force is provided by Coulomb's law. For the direction of the electrostatic force, use the following interaction statement. Similar charges repel each other, while opposite charges attract each other. When we say similar charges and opposite charges, we're talking about the polarity of the charges. We're talking about the positive, negative sign of the charges. Similar charges have the same sign. Positive, positive, or negative, negative. Similar charges will repel each other. While opposite charges, charges with opposite signs, so positive, negative, or negative, positive, opposite charges will attract each other. So you have the direction of the interaction, which will provide you with the direction of the electrostatic force. So magnitude of the electrostatic force, you have Coulomb's law. And for the direction of the electrostatic force, you have this interaction statement. And that's it for now. That's it for our discussion on electrostatic force. We'll continue our discussion on the topic of electric charge and electric field in the next video. In the next video, we'll take a look at the concept of the electric field. So again, that's it for now, and thank you for watching.